Using symmetric points to graph. To sketch a graph of a quadratic function, standard graphing function. Y equals ax squared plus bx plus c, where b does not equal 0. 1. Find the y-intercept. 2. Find the y-intercept symmetric point. 3. Find the coordinate of the vertex, or I should say x-coordinate of the vertex. 4. Find the y-coordinate of the vertex. 5. Find additional points on the parabola for better accuracy. And 6. Sketch the parabola that contains the point found. Okay, let's try an example. In this case, we're going to try to graph the equation y equals x squared plus 2x minus 7. Our first step is to essentially find a y-intercept, meaning we're substituting 0 for our equation y equals x squared plus 2x minus 7. So step 1, well, I'll just recopy my formula and substitute 0, y equals x squared plus 2x minus 7. Just for reference, I'll enter in the blank spots as well on the left side, but I'll recopy over here on the right side to make it a little bit easier to visualize. So once again, substituting for x, I'm replacing the x value with a 0 since that tells me it's a y-intercept, right? When x equals 0. So now in this case, we get 0 squared, 0 squared, 0 times 0, 0, and 2 times 0, 2 times 0, 0. Okay, so we get y equals 0 plus 0 minus 7. And of course, 0 plus 0, 0, minus 7, negative 7, right? So y equals negative 7 is our y-intercept then. Or we could have realized that just looking at the last digit that has no x, because that's the only variable or number, I should say, that will not equal 0 for this particular case. So there we go. Let's plug it into our coordinate over here on the left side. And we could probably define it as the y-intercept, right? Since it's 0, negative 7. And we want to give a quick sketch of our point that we just found. Let's label our x and y axis. And there it is, plotting the first point, which is our y-intercept. Now we want to find a symmetric point about the y-intercept. Be aware, if this by chance happened to be the lowest point or highest point, this may not work. So there is some chance that it may fail. But in this case, it probably won't. So going on to step number 2. Step number 2, we're going to find a symmetrical point, meaning it has the same y value of the y-intercept. So since the y-intercept has a negative 7, we're substituting negative 7 for the y value that we're looking for in this case. And of course, we're going to replace the value in step 2 for the y value. So the blank spot on the left, but in this case, I just write it on the right side. So we have negative 7 equals x squared plus 2x minus 7. Same equation as what we started with at the top, but substituting the y value because we know it in this case to be negative 7. Okay, solving for the x's. That means I can get rid of the 7's, right? So if I add 7 to both sides of the equal sign, that will cancel the 7's on both sides technically. Negative 7 plus 7 cancels out. Same goes for the other side. So we get 0 equals x squared plus 2x. Hey, look at that. It's a little more straightforward. Since both terms have an x, I could probably solve. One way would be by factoring. The other one, well, we could try by regular solving, right? Maybe a little more tricky though. So in this case, by factoring, I'll probably need only a set of parentheses since it's only 2 terms. And both contain an x, so I'm going to factor out one of the x's. If I factor out an x from x squared, x times what gives me x squared? Well, that means I have one x left in the parentheses. If I factor out the x from 2x, how many x's are left? No x's left, just a 2. Agreed? So there's my 2 that's remaining from the previous term. Okay, it looks like I factored completely. Can't factor anything else. So that means now I can split them up and solve using our solving technique via the zero factor property. Meaning we can split them up and set them equal to 0 individually. So 0 equals x, and also keep in mind, that's our y-intercept which we previously solved for. So we have that in step number 1. We don't need to do anything with that because that is our y-intercept. But our second answer, therefore, would be 0 equals x plus 2, and solving for x, that means getting rid of the 2. So minus 2 from both sides. 2's cancel out on the right side, giving us that x equals negative 2. Hey, look at that. There is our symmetrical point, the x value of it at least, because the negative 7, we already knew that. Okay, so let's plug it into our coordinate, -2. Notice I've changed the color on that one so that's easier to spot for which coordinate we're talking about. So -2 comma -7 is the symmetrical point about our y-intercept point. So we could probably plot that as well. Look at that. And I could probably tell that in between there at -1, x is -1, will be my symmetrical point. Hey, just getting a little ahead of myself, huh? So in that case, let's proceed and substitute. For step number 3, we're replacing, well, P and Q. P and Q are technically two symmetrical points, right? So it's the 0 and the -2 for our y-intercept in step 1, and the -2, which has a step 2, right? Finding the x value. So step number 3, symmetrical points, right? This is just what we're doing on the left side here, but I'm just restating it to make it easier to visualize. Notice symmetrical points, P comma S and Q comma S technically just means that you have the same y value. That's why they're horizontally y value equals the same. But the x values are different. That's why it's called P and Q. So our vertex, x value of the vertex equals P plus Q divided by 2. So repeating the steps just so you can visualize them makes it easier for you to see them, I guess. There it is. We've noticed that we got -2 in the previous step as our x value for the symmetrical point. And now we're replacing it for our x value of the vertex, which is 0 for our y-intercept value and -2 for our step 2 value that we found for x. There we go. That makes it easier for you to see. So simplifying, 0 plus -2, positive times a negative, still negative, right? So in other words, 0 minus 2 will give us -2. So -2 divided by -2, pardon me, positive 2. So -2 divided by positive 2, 2 divided by 2 is still 1, and negative sign at the end is -1 then, overall. So our x value of the vertex, -1. Hey, look at that. We just found the x value of the vertex, or what we would like to call, well, the line of symmetry as well. So in a sense, by finding the x value of the vertex, we found the location of the line of symmetry, which is at x equals -1. Somewhere in that line, we can find our, well, vertex. But we technically still need to find the y value. So that's going to be our last step, finding the y value. So step 4, finding the y value of the vertex. So let's rewrite the equation. Y equals x squared plus 2x minus 7. That's the original equation that we got from the beginning. But we must substitute the x value of the vertex that we found in the previous step. Okay, so substituting the x value of the vertex, the -1. So it'll be -1 squared plus 2 times -1, and then minus 7. Simplifying, -1 squared. Well, -1 times -1 is positive 1. 2 times -1 gives me -2, and then bring down the -7. So 1 minus 2 minus 7. -2 minus 7, they're both negatives. So quantities add, gives us 9, right? It's like borrowing $2, and I borrow $7 more. I borrow a total of $9. So -9, just say I borrowed. Use that if it helps. Okay, 1 minus 9 gives us -8. So there is the y value over the vertex. So the vertex, -1 comma -8 will be our final answer, right? And we can do a rough approximation based on our last point. Vertex, -1 comma -8, we can plot it. And once again, do a very rough approximation. Recommend you do more points than those to make it a better plot. But otherwise, with just those 3 dots, we can take a really rough approximation of what our graph or parabola would look like in this case. So there is once again our vertex. It's the lowest point, agreed, in this case. Lowest point since parabola is a U-shaped, meaning it opens outwards. Okay, so Vertex formula. Do realize we just went through one of the formulas, one of the many formulas. Notice that we got another formula that we can use that's much, much easier to use in many cases than the one we used previously. So the one we previously used is only if you know 2 coordinates that are symmetrical to each other. Then you use those 2 coordinates. If they're not symmetrical, then it'll be a little tricky. So be aware of that. It wouldn't work. But if we know the equation in the form of y equals ax squared plus bx plus c, well, then we can use this technique. So step number 1, find the x coordinate of the vertex by using the vertex formula. X equals -v divided by 2a. Hey, if you know the equation, why not use this one instead? It's much, much easier. And step 2, find the y coordinate of the vertex by evaluating f at the value found in step 1. So in other words, same step as the last step that we did in the previous example. So the vertex is the coordinate negative v divided by 2a, meaning the x value that you found. And since we previously found the x value, then that means we can plug it into the equation if we have one. Otherwise, we wouldn't be able to calculate the y value. So once again, backtracking real quick. This is when we know two coordinates, 2 points. Then we can use this particular formula for the vertex. Symmetric point, vertex formula. On the other hand, in this case, is when we know the equation y equals ax squared plus bx plus c. We'll start it out. So y equals ax squared plus bx plus c. And let's use the previous example, just so you can see it's much easier if you know the formula. So y equals x squared plus 2x minus 7. Highly recommend you get used to writing a equals, b equals, and c equals. We'll do that in a minute. Otherwise, x vertex equals negative v divided by 2a. Once again, in this case, we realize that, well, a equals 1. There's nothing in front of the x squared, so we assume it's a 1. B value, it's a positive 2, so plus 2 or 2. C value is a negative 7, so negative 7 for C. So x value of the vertex, negative v divided by 2a. Let's substitute the values that we just found. So x value of the vertex, there's a negative. Then the v value turns out to be 2, divided by 2 times the a value of 1 in this case. And let's simplify it out. On the top, it's still 2. 2 times 1 on the bottom, still 2. 2 divided by 2 now gives us, hey, look at that. We get negative 1. What did we get in the previous problem? We also got a negative 1, right, for the x value of the vertex. Once again, that only gives us the x value of the vertex. But now let's find the next step, step 2, the y value of the vertex, by substituting into the equation just like before, right? So the next step is going to be pretty much identical to what we did in the previous example. So substituting in, negative 1 squared plus 2 times negative 1 minus 7. Once again, simplifying it, it gives us 1 minus 2 minus 7. Simplifying that, it gives us 1 minus 9. And once again, simplifying that, I'm going to have to work to the right. Y equals negative 8. And finally, we can combine them into a coordinate, right? The vertex, finally, is negative 1 comma negative 8. Is that the same value we got previously? Hey, look at the graph there. Our x value is negative 1 comma negative 8, so it's the same value. But look how many steps we avoided. And we got the vertex location pretty straightforward, right? From here on, you can always pick any other x value to find, well, other y values, or make a table with them, right? So you can actually graph once again. Fairly straightforward. So let's declare it as definitely this works a lot easier, a lot better. Okay, next step, maximum or minimum value of a function. So for our quadratic function, y equals ax squared plus bx plus c, whose graph has a vertex h comma k. This is just what we were talking about earlier. The vertex, h comma k. So if a is less than 0, then the parabola opens downwards, and the maximum value of the function is k. So in other words, the vertex is pretty much the maximum or the minimum, depending on what it looks like. If a is less than 0, meaning a negative value, in this case the left graph that we have squared in red down at the bottom. And let me circle out down there. Okay, there we go. It's the maximum point in this case. So there's a maximum. The maximum value is the y value, well, 7.33, or x value 1.33, but technically the maximum would be the y value, 7.33. Okay, how about if a is greater than 0 then? Well, in that case, we have an example that's similar to the graph on the right. The parabola opens upwards, and the minimum value of the function is k. In other words, the lowest value. In this case, the k value, or the y value, negative 3.33 is the minimum. X coordinate, or the vertex coordinate, or coordinate point, negative 1.33, comma, negative 3.33. But the minimum technically is the y value, negative 3.33. There it is. I'll circle it, or circled, so you can visualize a lot easier. So if parabola opens downwards, there's a maximum. Parabola opens upwards, there's a minimum. Okay, previous example, the vertex was technically at negative 1 comma negative 8, meaning that negative 8 was the minimum value because it was a U-shaped and the negative 8 was the lowest point. 2 parabolas examples and vertex examples for you. Hope it helps.